Here we have the 2018 paper 2 for junior cert. Let's see the first 4 questions in this video. A bit of geometry, 2 questions on area and volume, and a probability question. Question 1, part A and B were worth 10 together. Part A, we're asked to write down the size of the angle X. We're given this circle with some triangles and shapes inside it. So we've got a 40-degree angle here. X is opposite the 40 degree. X is equal to 40. No explanation required, but it is opposite or vertically opposite to be technically correct. You may be asked to write down Y and the size of the angle Y. So we look at the diagram. We'll just draw it. Angle Y is in this triangle here. We have X already as 40. And what can we say in a circle? From the center to the edge of the circle, these two are radius. So we have an isosceles triangle here, where the 2 longer sides from the diagram end with the angle Y. So 2 Y's down here and 40 up the top. So the maths involved here, 2Y would be 180 minus 40. Or Y is equal to 140 divided by 2. So Y is equal to 70. So show as much work as you can in these exams. Part C, we're asked to find the angle Z. So let's look at Z. We have a cyclic quadrilateral going on here where opposite angles are going to add up to, well, let's just start with a rectangular square thing. Opposite angles in a rectangular shape. That's not a right angle. We'll add up to 180. Trying to do a right angle. Now if we move this slightly, if we move it 5 degrees, this one becomes 95, say, and this one becomes 85. They'll still add up to 180. So opposite angles add up to 180. So we have Z and if I just draw this cyclic quadrilateral 4-sided shape, Z, the opposite angle to Z is Y, so Z plus Y is equal to 180 from our little basic diagram, and we got Y to be 70, so Z is equal to 180 minus 70. Z is equal to 110 degrees. Nice easy start for your geometry in paper 2. Question 2 and 3 was area and volume. We had 55 out of 300 marks. Divide that by 3, you're going to get 18.33% just for area and volume. So give it your attention. A new action camera is sold in a box that's 5 cm high, 14 cm wide, and 24 cm long. Work out the volume of this box. You say, can this actually be this easy? Yes, they're always going to be easy questions throughout the exam. 5 by 14 by 24. The only thing not to do is guess the answer or try and work it out in your head. Use your calculator. And this is 5 by 14, 70 by 24 is 10 by 24, 240 by 7, 1400 and 280. Your calculator will work out 1680 for you. 36 of these boxes are packed together. 36 of them. Looks like we're multiplying this by 36. Let's have a look and see. And a cover that is 1 cm thick is put all around the outside of 36 boxes as shown below. We look at the diagram and we're going to work out the dimensions, the outside dimensions of this cover in centimeters. So this is the diagram given. So we have 4 going up and we have 3 going across. So let's look at the height first. The height is going to be 4 of these 5s, 4 by 5. So write down the maths, don't just write 20. And then we're going to have to add a centimeter in here, this guy, and on top this guy. So plus 2, 22 centimeters. Show your work. The width, we have 3 widths plus 2, 3 14s. 3 by 14 is 42. Plus 2 is 44 centimeters. And the length back this way, 1 2 3 going back, just double check on top, 1 2 3. Sometimes looks can be deceiving, so it's 3 24s. plus 2. And 324 is 72 plus 2 is 74 centimeters. And it was 10 for B, 10 marks for B, 5 for A. Part C, also worth 10, we're told the cover that's put around the box is made of plastic. Work out the volume of this plastic. Well, inside the box we know we have 36. We have 36 by the volume. And they were, just checking, they were 1680. 36 by 1680 will give us the volume of the boxes. That's 60480. And the volume of the whole thing was dimensions that we just worked out, 22 multiplied by 44 multiplied by 74. And if we multiply these three things, we're going to get 71,632. So that would be total volume of the whole thing. This is the volume of the boxes inside, so the difference has to be the plastic. So the difference between these, 71,622 minus 60,480, 142. Just double checking my work, it's 632. So that's going to leave 11,152. Volume is in cubic centimeters or centimeters cubed. So that was question 2. Another area and volume, question 3. Question 3 has a solid cone of a radius 5, as you can see in the diagram. Vertical height 12. So we've got, looks like a triangle here to find the slant height L. And it's Pythagoras, and it should be one of these triangles you already know the diagonal of. It's going to be 13. For us to find out the square root of 12 squared plus 5 squared. You are all experts on Pythagorean triples. This is going to give 13, and we're dealing in centimeters. The total surface area of the cone, I wouldn't expect you to remember the formula, so we're going to go to the formula booklet, get the formula for surface area of a cone. And just remember we have a circle in at the bottom of it, and we're asked for answering centimeters squared, correct 1 decimal place. So the curved surface area is pi r L. That's why we were asked to work out L. And the circle at the bottom is pi r squared. So we just fill these values in terms of pi. Pi by r, which is 5, by L, which is 13. It's going to give 65 pi. Plus pi r squared will be pi by 5 squared, which is 25 pi. So 65 and 25 is 90 pi. Sometimes they ask for the answer in terms of pi, but in centimeters squared here. Just press change on your calculator. 282.74, and that's going to be in cm squared. And there was 10 for part A, B and C here. Consistent marking scheme. In part C, we're given a net. We're asked to write down the radius and the circumference of the circle. Well, the circle was the one at the bottom. The radius was 5. Circumference is 2 pi r. From the formula booklet, 2 by pi by 5. Your calculator will initially give you 10 pi and 10 by 3.14. Correct 2, does it tell us 1 decimal place? It does say 1 decimal place. 31.4 centimeters will be the circumference. And if we imagine this guy is folded together to make the cone part, so this is going to be the height, which the height will be going in this direction. It's going to be L. So the radius of this one is 13, and it's the same arc. It's going to fold into the same circle, so the arc of this one will also be 31.4 centimeters. Go back and look at your cone, try and visualize this. And question 4 was worth 25, 10, 10, 10. Quite a short video to start paper 2. Probability. And there's actually a C part 2 here, but both parts of C were worth 5. So write down the probability that Hager wins this game. So he takes part in a chess competition, or she. In each game, it's a she can win. She can win, draw, or lose, and in each game she plays, each of these three outcomes are equally likely. So the probability that she wins the first game, well, she has a 1 in 3 chance. There's 3 outcomes, so she has a 1 in 3 chance of winning the first game. Then we're given this little probability table here. Game 1 and 2, we're asked to fill it out. It's like the 2 dice. So we have 3 outcomes along here and along here. And if you match them up, this one is WW, WD, WL, DW, DD, and DL. And this one's given LW. Then we have LD, LL. It says there's 9 outcomes because there's 3 by 3. You all know 9 outcomes. And then part C1. So the probability that Hager wins game 1 and loses game 2. Well, win games 1. There's win games 1. Win, draw. Win, loss is the only one that wins game 1 and loses game 2. Is the WL. So there's only one option out of 9. And then C part 2. Part 2, the probability that she wins at least one of her first 2 games. So I'm just going to circle them or square them. That's winning one of the first 2. So is that. So is the third one we've already circled. This one, she wins her second one. This one, she wins her second one. And none of the others have a win. So it's going to be 5 out of 9 is the probability that she'll win at least one of her first 2 games.